So very good morning, students. Welcome to IIT NEET Foundation Program or Focus C by Krishnaveni Talent Schools and the Mastermind Schools. So once again, I welcome all the Indresham branch students so far of class 8 students for today's session. As you can see on the screen, and you are well aware, my subject is physics. We are in class 8th, our ongoing chapter, electric current. Today we are going to have session number 6, probably the last session of conceptual part. Maybe next class we will have the worksheets. But before that, let me remind a small reminder for you all that we have test number 6 on 30th December, Monday. Syllabus is same, electric current. The total chapter of electric current will appear for the examination, what we learn in the 6 sessions, right? And maybe 7th session will go for some worksheets. But all these things will appear for examination. So prepare well. We have a lot of time, almost 10 days time is there after completing the syllabus. So prepare well and do best in exam, right? But before going to know about today's session, let us recall what we learned in last 5 sessions, which you can see on the screen clearly, right? You can see clearly wonderful color pictures and the topics what we covered earlier, starting from prehistory of electric current, right? Starting from prehistory of electric current to what is electric current and its units, what is electric potential, what is potential difference, what is EMF, what is Ohm's law, which shows the relation between current and potential difference. Then the new word comes resistance. Then we have the loss of resistance, will give a new word called resistivity. And now we are under the process of learning about the effects of electric current. So there are various effects there for electric current, which we are discussing one by one, right? So today we'll complete that effects of electric current and we'll close this concepts of this chapter, right? So there are various effects are there. And this electric current is very much applicable for us in our day-to-day life. So we cannot imagine our life without electric current, right? We are completely addicted. So we are in the last stage of the chapter, heating effects of electric current, you can see here. So we are discussing about what we discussed is here on your material, everything. Okay. What is electric current? What is the unit? What is electric potential? What is the potential difference? Then what is the Ohm's law? And what is Ohm's law? Gives the word resistance, electric resistance. Then we'll move to the Ohm's law circuit, how to correct the circuit for Ohm's law, verifying the Ohm's law. Then we see what is the resistance. Unit of resistance is Ohm. The conductance is the reciprocal of resistance, which is measured in Siemens. Right? Then factors affecting the resistance, length of the conductor, area of the cross section of the conductor, temperature of the conductor, and finally nature of the material of the conductor. From this we got new word called resistivity or specific resistance. Now we are in the process of learning the last synopsis, that is effects of electric current. So there are various effects are there in that. Especially we have the chemical effect here to discuss. So already we have introduced in the last class. Maybe all chemical effects only there, totally, I think. Yeah, magnetic effects also there lightly. So before that, heating effects also given that. So chemical effects we already seen in the last class. We discussed in the last class. That is, whenever electric current passes through a liquid conductor. Liquid conductors, now which are called electrolytes. Then what happened? The liquid conductor decomposes into ions. Decomposes into ions, and respect to ions are deposited towards either cathode or anode, which are called cations or anions. So by that you can separate a pure metal from the ore, which are used in the industries, and this method also used for electroplating, coating one metal over the other. I told already, 1 gram gold, or even stainless steel articles, utensils are made by the chemical effect of electric current, right? For this, you need to have good conductors. There are good conductors are there, bad conductors are there. The good conductors are those which allows the current to pass through them. Bad conductors are those which does not allow the current to pass through them. So electrolysis is a process where whenever current passes through any liquid chemical, the liquid chemicals are decomposed into components. That is called electrolysis. For that, we need two electrodes. Positive electrode is called cation. Negative electrode is called anion. Sorry, cation and anion, right? Okay, this is about completely chemical effect. So before going for the further explanation, see electroplating. We are coating one metal over the other. When you see your tap of wash basin, it looks steel. We say it as steel. But over that, is over iron, the chromium is coated. See, jewelries also. Gold-plated jewelries comes under they are done by the electroplating only. See here, some more examples are there. Tin-plated can. All these are the coating. Zinc coated on iron, used to make the bridges. But bridges also they coat because to avoid the rusting, erosion. Okay. So before going for the magnetic effects, let me show you one video on the chemical effects of electric current, right?
All matter is made of atoms. Protons and neutrons occupy the center portion of the atom, and the electrons revolve around them in a particular orbit. Electrons which are in the outermost orbit are responsible for conduction of current. Electrons flow from a body or point where there is an excess of electrons to a body or point where there is a deficit of electrons. In other words, electrons flow from a body that is negatively charged to a body that is positively charged. Objectives. At the end of this lesson, you'll be able to explain the structure of atoms, define conductors and insulators, understand the electrical conductivity of some liquids in general, identify the chemical effects of electric current, list the uses of chemical effect such as electroplating.
Right, total chemical effects. You can understand by end of this.
We classify the materials as conductors and non-conductors. Materials which allow electric current to pass through them are good conductors of electricity. Metals like copper, aluminium are few examples of it. Materials which do not allow electric current to pass through them easily are called as poor conductors of electricity. Materials such as rubber and plastic are the example of this. We use tester to test the conductivity of materials which are in solid state. Do liquids conduct electricity? Most liquids that conduct electricity are solutions of acids, bases and salts. Chemical effect and electrolysis. When electric current is passed through acidified water, water molecules split into hydrogen and oxygen. The two metal rods shown in the diagram are called electrodes. This type of effect produced by electricity is called the chemical effect and the process is termed as electrolysis. Can we use pure water in the place of acidified water? Find out.
Your water is a bad conductor.
Electroplating. It is common practice to coat articles made of cheap metals such as iron or steel with a thin layer of less reactive metal. A steel object, for example a spoon, is connected to the negative terminal of current source. The positive terminal is connected to the bar of the metal, for example pure silver. Thus the spoon acts as the cathode in the electrolysis, while the bar of the metal acts the anode. The electrolyte is a solution of salt that contains the ion of the anode metal, for example, silver nitrate. As soon as electric currents start flowing through the solution, electrons begin to escape from the silver anode. This results in the formation of positively charged ions, which separate from the anode and pass into the solution. There they migrate towards the cathode, attracted by its negative charge. When they reach the cathode, they accept electrons from it and change into silver atoms, which deposits onto the cathode in the form of thin metallic layer. The thickness of the layer depends on the conditions under which the electrolysis is conducted. This process is known as electroplating.
So like this only gold also plated.
Use of chemical effect for silver and gold plating. This type of plating is done to deposit a thin layer of gold or silver on surface of the other metal, most often copper. It gives a gold or silver finish to the artificial jewelry and ornaments. Silver-plated articles. Gold-plated articles. Did you know? Electroplating is widely used in industry for coating metal objects with a thin layer of a different metal. For example, chromium plating is done on many objects such as car parts, bath taps, kitchen gas burners, bicycle handlebars, wheel rims, and many others. Tin cans used for storing food are made by electroplating tin into iron. Thus, food does not come into contact with iron and is protected from getting spoiled. Iron is used in bridges and automobiles to provide strength. However, iron tends to corrode and rust, so a coating of zinc is deposited on iron to protect it from corrosion and rusting. Chemical effects of electric current. The passing of electric current through liquids or conducting solutions causes chemical reaction. More importantly, chemical activity may occur in the liquids around the electrodes. Bubbles of gas are formed, deposits of metal may be seen, and changes of color may occur on the electrodes. This reaction depends on what liquids and electrodes are used. The passing of electric current through a liquid causes chemical changes. This process is known as electrolysis. Summary. Let us summarize what we have learned.
So this is the what
Some
we learned
liquids
here
are good
about the chemical effects of electric current. Okay. So complete details about the chemical effects. What is the chemical effect? How one object is coated over by the other metal called electroplating. Right. Now next one is magnetic effects of electric current. You can see the magnetic effects. Right. Just a minute. So here you can see the magnetic effects of electric current. There is something missing here. So what happens when electric current passes through conductor? Every current carrying conductor produces magnetic field. It is observed by Henry Oersted in the year 1820. Whenever he placed the magnetic needle compass near the current carrying conductor, he found that the compass is deflected as long as you are passing the current. When you switch off the current, the deflections are stopped. That clearly indicates that every current carrying conductor produces the magnetic field. So this is a wonderful application of electric current, which is used mainly in electric bell, crane, electric motors, and many more. Right? This is electric magnetic effects. So that you can see here, electric pen can be used electricity to write anything. To make an electric pen, let us follow the activity. You can find the electric pen is nothing but tester only. Okay, CFL. So this is a method to find the electric pen, which is application of the magnetic effect of electric current. Okay. So chemical effect we have seen, magnetic. LEDs also comes under that. When you can use LEDs, light emitting diodes, in the tester instead of bulb, because LED glows even with weak electric current flows through it. With less current supply also, LEDs will glows when compared to bulbs. LED is the observation of light emitting, that is observation of light emitting diodes. There are two leads of the length of LED. The longer lead is connected to the positive terminal and shorter one is connected to negative terminal. There are two leads. Okay. Now when you come to our last synopsis, which deals with the heating effects of electric current. So many applications you can see. Heating effects of electric current. Whenever electric current passes through conductor, the conductor becomes hot. For example, bulb. Switch on the bulb for some time and touch it. It will become heat. Iron box, geyser, heater, room heater, which we can use nowadays during the winter. All these works on the principle of heating effects of electric current. But some of the conductors will become more hot, some of the conductors become less hot. There are some factors influencing the heating effects. That factors of heating effect is given by Joule's law. Joule is a scientist which will measure the work done or energy unit. So as according to Joule's law, so there are some formulas are there we have to recall. Okay, see here what Joule's law state, which is obtained from the simple, we know the definition, potential difference is equal to work by charge. Right? From this we get work is equal to VQ. From same definition of the potential difference, the amount of work done to carry a charge from higher potential to lower potential is called potential. From that electrical energy, the work done is given by V into Q. So what is V? V is equal to IR from Ohm's law. Q is equal to IT from the definition of current. So from this we get I square RT. W is equal to. Right? That is Ohm's law. W we can call it as H also, heat or work. So from that you can conclude that heat depends on square of the current, heat depends on resistance, heat depends on time. So what is the meaning? Heat depends on square of the current. If you pass, suppose 1 ampere of current through bulb, it may become less heat when compared to when you pass 2 amperes of current or 3 or 4, 5. Means when you increase the amount of current, the heatness increases. Similarly, when you increase the resistance increases, it stops the current more time. So heat again increases. Similar third one, if you increase the time, suppose switch on the bulb for 2 minutes and switch off and touch the bulb, you feel the heat. Same bulb switch on for 1 hour and then you touch, you'll feel the more heat, because more time we pass the current, more is the heat produced. So these three are the factors which are all together called Joule's law. According to Joule's law, the amount of heat produced by electric conductor is directly proportional to square of the current, resistance and time of passage of current. It is given by H is equal to I square RT. H is nothing but heat or energy, same only. Right? This is called Joule's law. Now, when is the practical applications? What are the practical applications of heating energy? So many, I told already, so many are there. Electric bulb, where the filament is the responsible for becoming heat, which is called, the filament is the made up of nichrome, nickel and chromium alloy. Then iron box. In iron box, there is a mica sheet which acts as a filament and becomes heat. When you go for the electric heater, electric stove, geyser, oven, many appliances which works on the principle of the heating effects of the electric current. Right? Clear? Some more are given here. You can see if anything is given. See. Then, after knowing about C, filament of electric bulb is made up of a thin wire called tungsten. The melting point of the filament is high, that is about 3380 degrees Celsius. The filament of the bulb is enclosed electric bulb is filled with the inactive gases like nitrogen or argon. Next, electric fuse also works on same principle. Whenever the fuse becomes very hot, fuse will burn and protects our electrical appliances. But the fuse is having the low melting point, a material with a low melting point. Okay, so these are the effects of electric current: chemical effects, magnetic effects, and heating effects. It's also called lighting effect. Bulb also will give light also, along with heat. Okay. Then finally, we'll conclude with the electric power. Power. So what is power? You know, power is nothing but work by time. Correct? Power is nothing but work by time. Electric power. So, you know, W is equal to, we have seen, as per Joule's law, I square RT. Right? We can write in place of this I square RT by T. Cancel TD. So what we get? Power is, electric power is given by P is equal to I square R. This is the one you can write. Also, you can write I square R, you can I into IR. Can we write? What is IR is equal to V? That is, you can write VI, power is equal to. Any of the formula depends on the given data. So electric power is nothing but the rate of electric work done, which is mathematically given by P is equal to W by T. But we know that W is equal to heat energy produced, which is given by Joule's law, I square RT. So TT cancel. We got I square R is the power of formula for power. But what is I square R? You can write I into IR. IR is equal to V. So V into I also is the formula for power. Potential difference into current. Okay. So when you say units here, generally power is measured in watt. But electric power is large power. So it is measured in kilowatt hour. What? Kilowatt hour is the practical unit of domestic consumption, electricity consumption. Generally, when you consume the electricity at home, we'll use the, when you are using the current at home, we'll use the measurement as kWh. That is equal to 1 unit. 1 kWh is nothing but 1 unit of current. You measure in units, na? Based on the consumption of, you get the bill. How many units you measured into some amount. So what is that unit is nothing but kilowatt hour. 1 kilowatt hour. If you go and see in your electric meter, you can find kWh on the screen. That is, it is measured in 1 kWh. That is called nothing but units only. What is kWh? How much energy it is? You know what is K? K is nothing but kilo. Kilo means 1000. What as it is will keep. And hour is how many seconds? 3600 seconds. That is equal to 36 and 5 zeros are there. 36 into 10 power 5 watt into hour, watt into second. Because we can watt as it is, hours we convert into seconds. Watt second. Watt second is nothing but joule. How? Because we know power is equal to work by time. Power is nothing but watt. Right? Work is nothing but joule. And time is nothing but second. When second goes this side, watt into second is nothing but joule. So this many joules when you consume the current, it is considered as 1 unit. So 1 unit or 1 kilowatt hour is equal to 36 into 10 power 5 joule or 3.6 into 10 power 6 joule. No confusion. Right. This is the practical unit of electricity consumption at our house, which is given by the formula power is equal to V into I, or P is equal to I square R. Anything you can use, power, electric power. So electrical power consumption is given by a largest unit called kilowatt hour. 1 kilowatt hour is nothing but, in our domestic purpose, we call it as 1 unit. 1 unit is equal to 3.6 into 10 power 6 joule or 3.6 into 10 power 5. So 36 into 10 power 5 joule, anything. That you want to given in the end of the page, you can see. So this is complete explanation about the electric current and its effects. We have seen the chemical effects, magnetic effects, heating effects, and of course, brief about the light effect. When you pass the current, light is comes. It may be LED, or it may be CFL, or it may be ordinary bulb, or it may be tube light. They not only produce the heat, they also produce the light also. Right? So are you clear? So with this, we have finished our entire chapter. So further, when you go for the next class, we'll try to solve some worksheets on this, and some solved examples are there, which is a part of your test number 6. Right? So you can see it's signed by the homework. The homework, you can write the question, state and explain Joule's law. Joule's law is nothing but heating effects. So write down the question, write answer in your notebook along with the important points. Right? And take the signature from your parents and teachers. Okay. Thank you, Mitchell. So that's all for today. Thank you, all of you. Have a wonderful day.